Hi, my name is Jamal Robinson. I'm a cloud solutions architect. I'm here today to give you an introduction to OpenStack. On the last video, we covered some administrative tasks such as adding a project or user. In this video, we want to get into some of the common compute tasks. I'll start by logging in. Under the Compute tab, I'll get to the project overview. This shows me the number of VMs that I have launched, along with the project quotas and how full they are or not. If I were to switch to another project by using this drop-down, I can see the quota for that. Notice in the admin project I have no VMs. Switching back to demo, I can see that I have one VM launched. Under the Compute tab, I have an overview. I have an Instances tab that lets me manage my VMs. I have a Volumes tab where I can manage my volumes, creating new ones or backing up or attaching them to different VMs. Also, I have an Images tab which allows me to manage my images that I want to launch a VM from. Access and Security gives me the ability to firewall off my VMs from other VMs or access to the outside world, and also gives me access to the API and floating IPs. We'll start with the instances. This gives me a view of existing VMs and allows me to launch new ones. You can see I currently have a VM called lamp-web server. I have the ability to create a snapshot with that VM, and from the drop-down you can see I can do a lot more. Let's click into the VM to see more details about it. Under the Action Log tab, I have the ability to see what's happened with the VM. So far, all I've done is created the VM. If I were to have restarted it, paused it, or done anything else, you would see that in the Action Log. The Console tab, if I had this enabled, would actually show me a terminal input into the VM where I could interact with it. This log is the initialization log, which is beneficial if you're having any issues booting up your VM. In the Overview tab, it gives us different attributes about the VM. Now let's launch another VM. We'll call this VM Test VM. And then we'll choose the Ubuntu 14.04 image. If I wanted to add a key pair, I could enter my name here and paste a public key, but for this case we won't. For security groups, it shows me all security groups available, which right now only have default. And for networking, it shows me all my virtual networks, which I only have private right now. Under post creation, I have the ability to add a file of metadata to the VM or put direct input. This metadata will be managed by Cloud-init if the VM currently has Cloud-init installed. Cloud-init is a service that runs on boot and takes advantage of any metadata supplied to the VM. I'm going to paste script data here, which says that I want you to set the password for the default user. In this case, my password is Ubuntu, and say that I don't want the password to expire. If you're wondering about the Cloud-init and where I got these examples from and where you can find them at, there's numerous examples online. Here's an example of a cloud config repository that has a lot of different templates that you can use. For example, this one shows how to add a repo to your Linux-based VMs. These are all comments, and below is where the actual work is done to set the Ubuntu repository. We'll leave the user data so the username and password is set upon boot. And now when we go to advanced options, we see that we have the ability to manually partition the disk. Instead, we'll leave it at automatic and hit launch. The request has been successful, and now in the background, it's in the process of trying to spawn the VM. Our VM is now running and assigned an internal IP address of 10.0.0.4. And also because I have IPv6 enabled, an IPv6 address has also been given to the VM. If I wanted to create a snapshot or a backup of the VM, I had the option to do that. If I was having issues with the VM, I could say resize it and give it more virtual CPUs or give it more memory. If I wanted to suspend the instance, I could do that. And ultimately, if I wanted to terminate the instance, I have that option here. Or I could check in this box and hit terminate instance here. But let's now move on to access and security now that we have our VM launched. When we click on access and security, we can see the default security group. If I click on manage rules, I'm able to see the default rules. In this case though, let's create a new security group. We'll call it web-ssh and give it a description. And now we'll go and add rules to it. Right now it only allows outgoing traffic to any IP address. Let's add a rule for web. So there are default rules that are set up in here. So port 443 and 80 are HTTP and HTTPS. We can either select that or we can say custom TCP rule and add it ourselves. So this rule will allow port 80 traffic from any IP address. We could restrict that to a specific set of IP ranges. We'll click Add. Now that we've done that for HTTP, let's do it for HTTPS. And we also want to allow incoming SSH traffic. Now we've successfully created a group called web-ssh, which allows any web traffic along with SSH traffic. Let's go back and apply that to our VM. From the drop-down, we click Edit Security Groups. We'll add the security group we want and remove the security group we don't want, and click Save. And these changes will take effect immediately. If we go back to Access and Security, we see we also have options to manage our key pairs here. I can create a new key pair, give it a name, and a key pair will automatically be generated, and gives me an option to save. Or I could choose to import my own key pair of an existing key that I already have. The same option we had during the wizard to launch the VM. Under Access and Security, you also have an option for floating IPs if your system has some. Floating IPs can be valuable because you're given one IP that can be assigned to multiple VMs. This way, if you have to take a VM down for maintenance and you don't want to lose traffic on, let's say, a web server, you can switch that floating IP over to use another web server, and that way your traffic isn't lost, or people trying to connect to the web server don't have any issue. API access is something else you can find under Access and Security. These are the URLs you'll use as service endpoints. You're also given access to an OpenStack RC file. Let's open that up. This OpenStack RC file is configured for our user automatically, gives us our URLs, gives us our tenant name and project name, and also the username. From a Linux-based system, I would source this file, give my user credentials for the admin account, and this would give me the ability to use command line tools like the Python OpenStack command line tools to interface with OpenStack through a CLI. The OpenStack documentation page gives us examples of how to use the command line tools. We can look and see that they have a bunch of examples. Let's focus on something that we've already done with the Horizon interface, which is launching an instance. Notice through the command line, we use the name of the project for compute, which in this case is Nova, and then we say flavor list, which gives us a list of all our available flavors. And then we say Nova image list, which shows us the images that we have available to us. Next thing we do is we check our security groups, and then we look at our available key pairs. After we note all that, after we've gotten all the information on the previous page, we now actually launch a VM using the nova boot command. This is an example of launching a VM along with the outputs you can expect when using the command line tool. Now that we've taken a look at launching an instance through the Horizon dashboard, but then also through the CLI, let's also take a look at volumes. Volumes represent block storage in OpenStack and goes by the project name of sender. To create a volume, we click Create Volume and fill out the information and then click Create Volume. The volume has now been successfully created. To attach this volume to a VM, I want to click on Manage Attachments, select an instance, and then choose to attach. I've now just successfully attached a 2 gig volume to my VM, which for the Linux instance will be available on /dev/vdb. If this was a Windows instance, you'd have to go to Disk Management and initialize the volume from there. If I wanted to back up my volume or make a copy, I would click the volume and choose Create Snapshot, give it a name and a description, and then choose Create Backup. My backup has been successfully created. From a backup, you have the option to create a new volume. Now let's take a look at images. Images in OpenStack or the Glance project are responsible for images you use with your VMs. Right now you can see that I have Ubuntu 14.04 image in my project. And overall, every project available in this OpenStack installation has a total of 4 images available to it. To launch a VM off the instance, I can click Launch Instance, or if I want to create a new image, I click Create New Image, and start to fill out the name and the description. Back on OpenStack.org, I can get different cloud images. In this case, let's choose the CentOS image, and we want CentOS 7. I'll choose a QCOW image, and paste that into my image location. If I wanted to, I can choose Image File and upload an image from my local computer. Of the available formats, we'll choose QCOW2, and the rest we can leave blank. If we wanted to set a minimum disk, say for instance if you knew your image needed 20 gigs as a root partition or else it wouldn't work properly, you could set 20 here to make sure that nobody launched the VM with, let's say, 10 gigs and the VM would malfunction. We also have an option to make it public. If we don't check this, it's only shared in our project. And then we can protect it, meaning nobody can accidentally delete it. We'll check both of those and click Create Image. The CentOS 7 image has now been successfully added to our repository. If I go back to instances, I have the ability to launch a new instance. And when I choose Image Now, you can see that CentOS 7 is an option for me. I also want to show you how to back up a VM. So if I click on my LAMP web server and say I want to create a snapshot, we'll call it LAMP Backup, and then start to create the snapshot. Snapshots in OpenStack are an image captured from a running instance. Functionally, these are the same as regular images. My backup is now completed successfully. The benefit of having this backup is if I do anything to the VM from this point on, I'll have this point in time reference to go back to, where I could delete the VM and relaunch another VM based on this backup. Knowing that I had all my changes saved and none of the new actions that I took on the VM since making a snapshot would be applied here. The same way we can launch an instance from an image, we also have the option to launch an instance from a volume. When I click Launch Instance, let's say for M1 Tiny, I can choose Boot from Volume. The benefit of going this route is when we terminate a VM, if you booted it from a volume, that volume is still available. so you can relaunch the VM later using the exact same volume rather than having to start from scratch. We'll cancel out of this and now navigate to object storage. Object storage, which is a Swift project in OpenStack, works very well for unstructured data sets where data is generally read but not written to. Static web content, data, backups, and archival images, and multimedia such as videos, pictures, and music files are best stored as objects. Geographically distributed backend storage is another great use for object storage. If you have any questions how other users are using OpenStack and object storage together, you can navigate to openstack.org/user-stories, and it'll show you the different companies that are using OpenStack, along with how they utilize object storage in the case studies. Now, navigating back to object storage, I have the ability to create a container. A container is just a logical item that holds all my objects. We'll view it as a bucket. You have the ability to make it private or public. Private meaning those in OpenStack have access to it. Public meaning those in the world have access to it. We'll make this bucket public. If I go to view details on my bucket, I can see the public URL. I now want to upload an object to this bucket by clicking on Upload Object. I'll browse to the file, click the file that I want, and choose Upload. The object was now successfully uploaded, and now artwork.jpg I have access on the public URL, and anybody using that public URL will have access to the file, along with anybody using any Swift command line tools to access it through the API. I can also download or delete objects from the interface that other users have created too, using this tab. So that's it for our brief introduction to the common compute task in OpenStack. I hope that this gives you a better idea of what you can do with OpenStack. In the next video, we'll try to cover some of the networking capabilities of OpenStack. Hope this was helpful, and thanks for your time.